Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad DANIAL bin Muhammad AZRY and my metric ID is MA18176 and I want to present about the abstracts. Bernoulli principle is the subject of this experiment. The aim of this experiment is to illustrate Bernoulli principle. The Bernoulli principle demonstration apparatus is used in the experiment. The apparatus is made up of many parts, including a ventometer, a pad of manometer tube, a pump, and a water tank with a pump, water controller, and a tubing. The ventometer is used in this experiment is to test the fluid flow through a vessel. The converging and diverging portion of this venturi tube work to increase and decrease the fluid velocity and lower and higher static pressure, respectively. After the level pressure of each manometer A, B, C, D, E, and F is equal and stable, the experiment is repeated 3 times with different flow rates, beginning with the first after the level pressure of each manometer A, B, C, D, E, and F is equal and stable. The flow rate was calculated when the water level indicator reached 3 liters. The head loss of each manometer is calculated as the level pressure. The velocity of fluid increased as they pass from a region of higher pressure to a region of lower pressure, according to the result of the experiment. By using Bernoulli equation and the continuity equation to determine velocity, there are minor variation in flow speed and pressure. As a result, we came to the conclusion that Bernoulli theorem is right and the experiment was completely successfully and the goals were
A very good day to my lecture and my beloved colleagues. On this wonderful day, I would like to present about the Bernoulli's principle, Lab 1 for our Fluid Mechanics Lab 2. Okay, first I'll be talking about Chapter 1. Will be our briefing of the project. Okay, for the briefing of the project, we'll be discussing about the Bernoulli's states that for an initial flow rise when the speed of the fluid happens at the same time with the decrease in pressure or decrease within the fluid potential energy. In the years 1738, the scientist Bernoulli Swiss has principle in his book Hydrodynamics. Bernoulli principles are often applied to various types of fluid flow, resulting in what loosely denotes by Bernoulli's equation in the fact of the totally different from the Bernoulli's equation of various types of flow. Okay, for Bernoulli's we'll be having few types of flow. For our experiment, we'll be talking about 3 types of flow with a different angle of the pipes. Moving on to my problem statement. Okay, our problem statement in the Bernoulli's of the theorem experiment, the validity of the Bernoulli's equation known by the use of Venturi system connected with the manometer to measure the pressure, head and the total head at the point through the flows steadily. Okay, for moving on to the objective, we'll be having 3 main objectives. For the first objective is to design the complete measurement techniques for fluid flows and viscosity of the incompressible fluid through Bernoulli's theorem. Okay. For the second will be to validate the Bernoulli's equation when applied along a streamline. Moving on to the third objective will be to indicate the variation of pressure through converging diverging pipe section. Okay, this is where our setup of our Bernoulli's experiment will be done by the help of converging and diverging pipe section with different types of angle. Moving on to the scope. For the scope of the experiment will be Bernoulli's equation derived by assuming the velocity of each element of the fluid along the cross-sectional of the pipe is uniform. Okay, as mentioned, almost all the cross-sectional, the area of the pipe is constant from the beginning to the end of the experiment. That practically not possible, where there is always be an external force which will be acting on the liquid, which will be affects the flow of the liquid. Okay, this will be our main part where the external force is the main comparison force which will affect the flow of the liquid and will be compressing the velocity of the pipe to be changed. Besides, the kinetic energy is also converted to the heat energy and also energy losses occurs because of the shear force. The centrifugal force is neglected because in the Bernoulli's equation, we will be neglecting the centrifugal force on the left side and the right side in order to balance the equation to us to find out the velocity, or even we can find out the external force too, when the liquid flow is curved in the part with different types of angle and also with the different types of degrees. Moving on to the chapter 2. Chapter 2 will be talking about the theory of the Bernoulli's principle, where the states and the increase of fluid speed occurs at the same time as a decrease in the state pressure or decrease in the fluid potential energy in fluid dynamics, while Bernoulli deduced the pressure decrease as a flow speed increase. This will be our theory, which was being conducted by Leonhard Euler on the first derive of Bernoulli's equation in the current form of 1752. Moving on to our third chapter for the methodology on the procedures apparatus for the experiment. We'll be having 11 different types of 11 accordingly fixed procedure. For the first procedure, the pipe valve, manometer valve, and the water flow controls valves are guaranteed to be entirely open, while pipes valve is guaranteed to be half open. Okay, to the second one, by raising the speed of the water flowing by regulating a water flow valve, the motor pump is started so that the water was overflowing in the manometer. Okay, for the third one will be single pipe manometer valve, and the manometer valve will be both turned off. For the fourth one, the pump of the switch off and the pipe valve was closed at the same time, while the pipe valve 1 remains open. Okay. For the for the for the number 5, procedure number 5, for the step number 5, the manometer valve and the single pivot manometer valve were carefully opened to allow the ambient air into the system. To the sixth and the step number 6 to 9 will be doing it with different types of angle, and also with six different position of the pivot head, static heads, and the venturi tube were reads and been recorded for our experiment as our results. And number 10 will be the reading of the static head and the pivot head were recorded and tabulated with the help of the Bernoulli's equation. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikhwan bin Nazri, ID number MA18103, and I will proceed with the result, graph, and discussion. For first table, we have point, head start, head pivot, head total, head dynamic measure, and head calculated. For dynamic head measure, we use formula head pivot minus head start, while for the dynamic head calculated, we use V square over 2G. After getting the data, we plot graph of total head and head dynamic measure and head dynamic calculated against point. The graph shows that both measure and calculated dynamic head are close to each other with identical pattern. The graph increased until point 3, which is the peak, and the graph gradually decreasing after point 3. Then we proceed to the data of measure and calculated velocity, which we get from formula square root 2g head dynamic measure over 1000 for measured velocity and q over a for velocity calculated. A graph velocity measure and velocity calculated is plotted from the data that we get from the calculation. From the data, we can see that the graph increased gradually and then decreased rapidly. The highest point of the graph is at point 3 because point 3 has smallest diameter, which is 14 mm. This means that the cross-sectional area of the tube at point 3 is smallest, causing the velocity to be increased. Lastly, we tabulate the data for the pressure dynamic measure and pressure dynamic calculated. The formula that we use for pressure dynamic measure is rho g times head dynamic measure, and for the pressure dynamic calculated, we use rho g times head dynamic calculated. For the last graph, the pattern of the graph is also same, with increasing and decreasing after reaching highest point, which is point 3. Overall, the measured and calculated data of this experiment do not deviate much from each other, showing that the result is reliable and the efficiency of the system is high.
According to Bernoulli, a high velocity of fluid flow results in a low pressure and a smaller field results in a higher velocity. As a result, both equations were found to be capable of determining the velocity of fluid flow in a manometer. Even if the value is not identical, the trend of rising and decreasing at the converging and diverging portions is identical. As a result, for both convergent and divergent flow, the total head pressure rises at the velocity rise. So that's all from us. Thank you.